Welcome, my friends. We are talking about exponential functions today. An exponential function is where x is in the exponent. Exponential functions are widely seen in the world when you are talking about radioactive decay with a certain half-life, when you're talking about population growth, when you're talking about interest rates. Those are all exponential functions. We have a standard exponential function where you can either say f of x equals a times b to the x, or you could say y equals a times b to the x. Both of these are appropriate notation. F of x just means we're talking about a function of x. Notice that in one I use the dot and the other I use parentheses. The x is only connected to the b, it is not connected to the a. Otherwise, we would have a, b together, both raised to a power of x. The way in which you evaluate an exponential function is you substitute in the x value into some given equation. You take the exponent and then multiply it by whatever that constant is to find your value. Let's say I had y equals 2 times 1/3 to the x, and I wanted to find the function value at 2. That means I'm going to take 2 times 1/3 squared. 1/3 times 1/3 is 1/9. 2 times 1/9 is 2/9. Again, we evaluate the exponent first and then multiply it by the a term. Exponential functions either get larger and larger or smaller and smaller. But the thing about exponents, if you think about a negative exponent does not make a value negative. It actually makes it into a fraction. What I mean by that is if I said y equals x to the n, just using exponent rule notation, and then I said y equal x to the negative n, all y equal x to the negative n means is that's the same thing as 1 over x to the n. Let's take this 1/3, or let's take 3. What if I had y equals 3 squared? And then I said, or y equals 3 to the negative 2. That does not become -9. That becomes 1 over 3 squared, which is 1/9. The value is still positive. My function is still positive then in these situations, which means that I'm never getting to be negative in my function value, which means my y is never negative. That's my range. In my domain, when I'm looking at this exponential growth or exponential decay, I can substitute any input value. I can put in any x value. I can put in positives and evaluate that. I can put in negatives and evaluate that. I can even put in a 0 because anything to the 0 power is 1, which means my domain is all real numbers. If you've seen any of my other videos describing functions, you know there's multiple ways that you could write this. You could use the bold R for real numbers. You could use interval notation saying from -infinity to infinity. You could use set notation where you're talking about the set of x such that x goes from -infinity to positive infinity. All of these are appropriate methods. It just depends on what your instructor is looking for. In terms of the range, though, if I'm talking about the fact that I plug in any positive, I'm going to get a positive number. If I plug in any negative, I'm going to get a fraction that is also a positive, unless I have a fraction in there. And anything to 0 power is 1. Positives are going to give me positive. 0 is going to give me positive. Negatives are going to give me positive, which means that my range is not all real numbers. My range is going to be more than 0. I cannot get 0 from an exponent. Something to the 0 power does not give me 0. It gives me a number. I'm either going to get really, really big or really, really small, but I'm never going to get to 0. My range is then y greater than 0. A set of all y's such that y is greater than 0. Not greater than or equal to, which means that my interval notation would be from 0 to infinity. Now, if we transform our function and we make some sort of vertical adjustment, my range is going to change. If I have a reflection, my range is going to change. I need to be knowledgeable about what transformations do to my function in order to adjust my range, but my range is not always going to be y greater than 0 unless I have my standard parent function. If I do some sort of transformation, my range is going to change. So please keep that in mind. Notice I did not use the definitive will. Transformations can change the range because if I do a vertical stretch, that doesn't necessarily mean that my range is going to change. You have to be careful. Sketching a general graph. When we have, let's say, 2 times 1/3 to the x, we're substituting in values for x, we're plugging those in, and we're getting some sort of evaluation for the function, then we're graphing those. Let's say I have my standard parent function of y equals 2 to the x. And I'm going to use x values of -2, -1, 0, 1, and 2. F of -2 is equal to 2 to the -2. That's 1 over 2 squared. 2 squared is 4. That means I have 1 over 4. For x equals -2, I have 1/4. F of -1 is 2 to the -1, which is 1 over 2. -1 is then 1/2. F of 0 is equal to 2 to the 0 power, which is 1. For 0, I have 1 as my function value then. F of 1 is 2 to the first power, which is 2. I have the coordinate 1, 2. F of 2 is 2 squared, which means for 2, I have 4. And then I plot these points. At -2, I am at 1/4. At -1, I'm at 1/2. At 0, I'm at 1. At 1, I'm at 2. And at 2, I'm at 4. For the x value of 3, 2 to the third is 8, which means I go through the point 38 as well. This is a standard parent function. If I was to take 3 to the x, I would be talking about -2, 1/9, -1, 1/3, 1, 3, 2, 9. But 0 would be 1. Regardless of your function, if you have it in the form f of x equals b to the x, it is always going to go through the point 0, 1. Your parent function will always go through 0, 1 because anything to the 0 power is 1. If I make some sort of transformation, if I shift it up, down, left, right, there's going to be a difference. But my standard parent function goes through 0, 1. This is an exponential growth because my base is greater than 1. That means your graph is going to take on the function that looks like this. It's going to, on the negative x's, get closer and closer to 0, which is an asymptote. And on the positive x-axis, for all of the positive x's, it's going to increase without bound. It's going to increase to the right and increase up. Y goes to positive infinity as you go to positive x. Y goes to 0 as you go to negative x, but it never gets 0, never approaches 0. It just becomes smaller and smaller and smaller. If you had exponential decay, when your b is between 0 and 1, when you have a fraction that's less than 1, your graph is decreasing. We call that exponential decay. Your graph is going to basically reflect over the y-axis, and it's going to decrease as you get towards positive x's. Y goes to 0 almost. And as you go to negative x's, y goes to positive infinity. Let's do this chart for 1/2 to the x. F of -2 is then 1/2 to the -2, which is the reciprocal. I then have 2 over 1 squared. So 2 squared is 4, which means I have -2, 4. At -1, f of -1 is equal to 1/2 to the -1, reciprocal, 2 over 1 to the 1. At -1, we have 2. 1/2 to the 0 is 1. f of 1 is 1/2 to the 1, which is 1/2. F of 2 is 1/2 squared, or 1/4. As you can see, the black and the green graphs are reflections of each other across the y-axis. Think about it this way. It's a negative exponent. And remember, when you're talking about transformations, when you have a negative inside the function, it's a reflection across the y-axis. This makes sense. I mentioned asymptotes. For your standard parent function, without any transformations, my range is approaching 0, but it never achieves the value of 0, which means we have an asymptote at y equals 0. Transformations take on the same identities as before. If you do something outside the function, it affects it vertically. If you do something inside the function, it affects it horizontally. Inside the function is in the exponent. Outside the function is not. So when you're stretching something horizontally versus vertically, are you in the exponent or not? Inside is in the exponent, outside is not. I recommend you see the transformation video just to remember adding on the outside means you shift up, subtracting on the outside means you shift down, adding on the inside, you shift left, subtracting on the inside, you shift right, and then multiplying will stretch, negatives will reflect. I hope this was helpful in explaining exponential functions. Have a great day.